This is question 2 on chemistry from the 2014 BMAT. So we're asked which of these are redox reactions. So firstly, copper sulfate and zinc form copper and zinc sulfate. Then hydrochloric acid and sodium hydroxide form sodium chloride and water. Then magnesium and sulfuric acid form magnesium sulfate and hydrogen. Then lead nitrate and potassium iodide form lead iodide and potassium nitrate. So firstly, what is a redox reaction? It's a reaction where something is reduced while something else is oxidized. And so, which of these are redox? And how do we work it out? So, we're going to need to look at the oxidation states of each element in these and see if they change throughout the reaction. And so, how do we work out oxidation states? We use a set of rules which we need to remember. And what are these? So firstly, any element by itself is zero oxidation state. So we have zinc, copper, magnesium and hydrogen, which are all zero. Next, what about oxygen? We know this is always -2. So let's put all these in, except when it's in a peroxide, but there are no peroxides here. And what's next? How about hydrogen? We know that when hydrogen is in a compound, it's +1. So let's put these in, except when it's in a metal hydride, but there aren't any metal hydrides here. And what about halogens? We have chlorine and iodine present, and we know that when these are in a compound, they are -1. We also have some group 1 metals, that's sodium and potassium. And what are these when they're in a compound? That's +1. And we have a group 2 metal, that's magnesium. What is this? That's +2. So we've applied all the rules that we can, so let's try and work out for ourselves what the rest of the oxidation states are. So let's start from the top. What's copper in this? Well, we know the sulfate ion has a -2 charge, and so copper must be +2 to compensate for that. And we have zinc sulfate at the end, so we know zinc is also going to be +2, and so that just leaves sulfur to work out. What is this? Well, we have 4 oxygens that are each -2, and we know sulfate is 2-, so what is sulfur? That must be +6. And because it's the same version of sulfate here, we know that's +6 as well. So that's reaction 1 done. Reaction 2, we've already completed just by using our rules. Then what about reaction 3? So it's just the sulfur that's missing, and because it's the same sulfate we had before, we know it's going to be +6 here and +6 here. And finally, what about lead in this? Well, we know the charge of the nitrate ion is -1, and we have 2 of them, so lead has to be +2. What about the lead here? Well, we know iodide is -1, and we have 2, so again, lead is +2. So that just leaves nitrogen that's not completed. So what is it here? We've got 2 nitrates that are each -1 charge, and we know that each oxygen is -2, so 3 -2s are -6, and to get to -1 over rule, nitrogen needs to be +5. And because it's the same nitrate that's here, we know that's +5 as well. So we've assigned all the oxidation states, which is maybe overkill for this question, but we can at least be sure that we can see if anything's being reduced or oxidized. So firstly, what about reaction 1? Well, copper is going from +2 to 0, so it's being reduced. And what about zinc? It's going from 0 to +2, and it's being oxidized. So this is indeed a redox reaction. Now reaction 2, we have all of the elements this side in the same oxidation state as they're in this side. It's just a simple acid-base reaction, so this is not redox. Reaction 3, we can see we've got magnesium 0 going to magnesium 2, and we've got hydrogen 1 going to hydrogen 0. So similarly to reaction 1, this is redox. And finally, in reaction 4, the lead is always +2, the iodine is always -1, nitrogen is always +5, and this is just a simple ion substitution reaction, so it's not redox. So we have 1 and 3 as redox reactions, which corresponds to answer B on the question paper.